P4.
Ada, madam.
Okay. So P1 dengan P3 tak ada lagi.
P3 ada, madam.
I only have 78
P1 ada, madam.
of you. I only have 79 of you. 79 is including me, myself. Anyway, I need to start. Just make sure I've recorded the session. All right. Okay, so we will start on your lecture 5 today. Talking about your topic 3, we will try to cover your 3.1 galvanic cell. Okay. In your topic 3, you will have 3 subtopics, your galvanic cell, Nernst equation, and your electrolytic cell. And all of them are under electrochemistry. So first and foremost, we'll look at your galvanic cell, and the most important thing in your galvanic cell, or the most basic, is how do I draw a galvanic cell? Galvanic cell have another name. Galvanic cell can also be called as a voltaic cell. They are the same thing, all right? Galvanic cell or voltaic cell are exactly the same thing. So a general drawing, what I'm trying to show you over here is a general drawing of your galvanic cell. You need to have 2 beakers, okay? You need to have 2 beakers. You are going to have 2 electrons, okay? Both of the electron will be connected through your voltmeter, okay? You will have a voltmeter connected to the electron, okay? Yeah, cukup besar, cukup lah, boleh lah. Okay, and then you need to show what is your electron. So let's say this is my anode and this is my cathode. Okay, so we have anode and cathode, as you all know, and as everybody know, anode must be the one that undergo oxidation, while cathode will always be the one that undergo reduction. Just a kind reminder over here, your anode cathode can change position. Dia tak semestinya duduk di kiri dan kanan, dia boleh berubah tempat. Okay, and then you need to have your solvent. Okay, you need to have your electrolytes, we call it. You need to have your electrolytes over here, and your electrolytes must have the same respective ions. Okay, so that is your electrolytes for your anode, and that is your electrolytes for your cathode. Okay, next we are going to have something that is very important to complete the circuit. We have one more thing that we call over here is your salt bridge. So you will have your salt bridge immersed, make sure salt bridge terendam in the electrolytes. That is what we call salt bridge. I'll show you the example of salt bridge and the function of salt bridge in a moment. Okay, so as you all know, anode must be the one that undergo oxidation all the time, and your cathode must be the one that undergo reduction all the time. Therefore, your electron will be always flow from your anode to cathode. Okay, your electron must always flow from your anode to cathode. The moment kita nampak elektron bergerak dari kiri ke kanan atau kanan ke kiri, always remember elektron mesti bergerak dari anode ke cathode. Okay, and last but not least, a kind reminder over here, or anybody can tell me, your anode will be the positive or the negative terminal. Anyone?
Negative.
Your anode in your galvanic cell will be your negative terminal, while your cathode in your galvanic cell will be a positive terminal. Thank you. Okay. Yang ni adalah cara general kita lukis a galvanic cell that you can obviously see. Kita ada 2 elektron. Kita ada 2 elektron in the beaker with 2 electrolytes yang disambung dengan salt bridge di atas, dan di bawah, di atas kita ada wire connected to your voltmeter turun ke dalam electrode. So that is your complete circuit. Electrode kepada electrode, electrolytes melalui salt bridge kepada electrolytes. Okay. So before I move on, The general thing that you need to know is your negative terminal is always for your anode. Anode always undergo oxidation. The positive is for your cathode. Your cathode always undergo reduction. Therefore, your electron must always flow from your anode to cathode. Okay, yang ni benda general lah. A better drawing, a better version of drawing is something like this. And if you look at my drawing over here, kita check benda yang penting dulu. If you look at it, I have my zinc as my electron. I have my copper as my electron. That's why if you remember I say when your electron is a zinc, your electrolytes must have the common ion of the electron. So your electrolyte over here is your zinc nitrate. Okay, that is your zinc nitrate. For your copper pula, copper kita guna kat sini adalah copper nitrate. That is the common ion that you have between your electrolytes and your electrode. The example of salt bridge that we have, potassium nitrate, that is your salt bridge. Nampak kot, jelas. So over here, something is missing. What is missing over here is who is the cathode, who is the anode. Why I'm trying to show you in this example is, if you look at the flow of electron, the flow of electron is from the zinc to the copper. If you look very carefully, it's from the zinc over here all the way down to the copper. That is my electron flow. That represent your zinc over here must be your anode and your cathode must be your copper. Bukan sebab dia duduk kiri atau bukan sebab dia duduk kanan ya. It's because of the electron flow indicate in your diagram. So that would then be your negative terminal. That would then be the positive terminal of your voltmeter. Okay. Just a kind reminder again, your anode must be the one that undergo oxidation and your cathode must be the one that undergo reduction. By the way, quick question. Oxidation means release electron or absorb electron. Anyone?
Release.
Release. Your oxidation will be your release electron. Sebab tu kat anode, alright? Sebab tu kat anode, elektron bergerak daripada dia. Sebab apa elektron bergerak daripada anode kepada cathode? Sebab anode undergo oxidation, dia akan membebaskan elektron. Dan elektron yang dibebaskan akan bergerak terkedek turun kat cathode. Cathode undergo reduction because we will accept electron. Okay, that is what happening in your galvanic cell or your voltaic cell. Okay, and from here you can see a quick question as well. We are having chemical energy to electrical energy, or we are having electrical energy to chemical energy. Kita berubah daripada electric kepada chemical or chemical kepada electric. Anybody?
Chemical kepada electric.
Yes, chemical kepada electric. Because if you look at my drawing, untuk siapa yang tak nampak, ada switch tak? Tak ada switch weh. Kita tak ada power supply. Bila kita tak ada power supply, what are we doing is, we are having your chemical reaction or your chemical energy changing to electrical energy. That's why we are having the voltmeter. Why are we having the voltmeter? So that we can read how much energy is produced. Okay, so that is the basic of your galvanic cell. Make sure you know who is your anode, who is your cathode. Make sure you can read your galvanic cell very nicely. And of course, make sure you can draw your galvanic cell. Okay, all right. The next thing that we can have from the galvanic cell adalah 5 benda ni. Okay, saya akan ajar tulis 5 benda ni. Your half equation. Half equation means you have your anode half equation, you have your cathode half equation from the diagram. Your overall equation means, another word for overall equation is your chemical equation. Kita combine anode cathode, kita dapat overall equation. We are going to look at oxidizing agent, we are going to look at reducing agent, and the new thing that we are going to look at, cell notation. Alright, we'll focus on cell notation. Yang lain bukan tak penting, yang lain benda lama, benda yang kamu biasa jumpa. Okay, so first and foremost, let's look at our anode cathode. Make sure you know who is the anode cathode first. That is my anode, guys. That is my cathode. Look at the electron flow. Then you will realize who is your anode and who is your cathode. And also another tip adalah terminal lah. Negative terminal anode, positive terminal cathode. Okay. Starting off with our half equation. So, half equation kat sini. Nak tulis kat bawah lah. Boleh tak? Boleh kat atas. Tulis kat bawah lah. Half equation. So half equation kita ada dua, kita akan tulis untuk anode terlebih dahulu. Kalau nak nampak senang, anode undergo oxidation. I would normally put anode and then bracket oxidation. So label over here anode, knowing that anode undergo oxidation already, which means dia akan release electron. Okay, so who will be the one that release electron? I have zinc and I have zinc 2+. Fikir logik sayang. Zinc akan bebaskan elektron atau zinc 2+ akan bebaskan elektron? Anyone? Yang positif akan bebas elektron atau yang neutral akan bebas elektron? Tak ada jawapan. Second question. Zinc and zinc 2+, which one having more electron?
Zinc.
Zinc is the one that having more electron because sayang zinc 2+ terhasil sebab kamu dah buang elektron lah kan? So zinc and zinc 2+, the one that undergo oxidation definitely is zinc. Zinc adalah electrode, so zinc solid will then become zinc 2+ aqueous plus 2 electron. That is your oxidation. Just a quick tips lah, a very quick tips. Kalau kamu kata oxidation release electron, bermakna electron mesti adalah produk. Okay? Vice versa, bila kamu kata dia cathode, dia undergo reduction, betul? Bila dia undergo reduction, kita accept electron. Sayang, bila kita accept elektron bermakna elektron mesti adalah reactant. Okay. And then look at here. I have my copper solid over here as my electron. And then in the solution, I have my copper 2+ electrolyte. Copper 2+. So, for my, what do we call this? For my cathode pula, half equation for my cathode adalah reduction. So, fikir logik, yang ni lagi senang. Yang ni memang nampak. Cu, neutral, dengan Cu 2+. Electron is a negative. Electron masuk ke dalam. Rasa-rasa siapa yang akan ambil elektron tu? Copper or copper 2+? Fikir logik ke? Copper 2+, betul? Easy. Because electron is a negative charge. My copper is a
Plus
positive
with 2
charge.
electron.
Yes. Copper 2+ aqueous will then plus with 2 electron, and then I will be forming my copper solid. Okay, that is my half equation. Half equation akan ada markah dengan syarat kamu label anode cathode. Jangan tulis half equation tapi tak ada kepala. Your half equation kena datang dengan label baru dapat markah. Okay. Next, what are we going to do is we are going to combine them and we are going to form our overall equation. So how do I form my overall equation? Simple. Syarat pertama adalah elektron seorang kena duduk di produk, seorang kena duduk dekat reactant. Itu syarat dia. Elektron kena cancel off each other. So what are we going to do is the electron must be in the correct stoichiometry to cancel off each other. Sekarang elektron teacher 2, elektron kita 2. So kita boleh cancel. Kalau elektron kita adalah 2 dengan elektron kita adalah 3 dan kita tak boleh cancel lah. Kita kena darab 3, kita kena darab 2. Itu maksud dia. Okay. So elektron kena sama, kita baru boleh cancel off and then kita combine. When you cancel off your electron already, what do we do next is we combine them. Everything that on the reactant remain on the reactant. Your zinc solid, your copper 2+ aqueous, and then your product remain your Zn2+ aqueous, and also your copper solid. And that is your overall equation. Okay, setakat ni. Okay, next. What are we going to move on next? Adalah your oxidizing agent and reducing agent. For my zinc over here, tak payah padam boleh lah. For my zinc over here, Zn solid. Okay, my question. My Zn solid over here is a oxidizing agent or reducing agent?
Reducing agent.
Reducing agent is the one that undergo oxidation. Alright, jangan jawab semua tau. Jangan tulis semua benda. If the question only asking for reducing agent, alright, who is your reducing agent? Reducing agent is the one that undergoes oxidation. So reducing agent adalah zinc solid. Ini jawapan paling senang. Ataupun kalau kamu konon cita-cita tinggi nak tunjuk pandai kan, kamu tulis zinc. Zinc salah. Tapi kalau kamu tulis zinc electrode, betul. Okay. Nampak beza? Kamu mesti kena tunjuk the one that undergo oxidation or your reducing agent is actually the solid. Sebab zinc ada dua. Ada aqueous in ion, ada solid in metal form. Okay. So make sure you write that. And therefore, vice versa, oxidizing agent, the one that undergoes reduction, your oxidizing agent, cara paling senang tak payah guna ayat. Copper 2+ aqueous. Okay, tu cara paling senang. Fasa semua kena ada, charge semua kena ada. Kalau gigi juga nak tulis juga dalam bentuk ayat. Okay, tulis. Tapi, make sure kena ada 2+. So copper 2 ion aqueous. Tak payahlah weh, tak payah gigil sangat weh. Tulis yang ni je. Okay, that is how we label reducing agent and oxidizing agent. Make sure the one that undergo oxidation, this is your reducing agent. Alright, make sure you remember that. And the one that undergo reduction, this one, your copper 2+ will be your, tak ada tempat, will be your oxidizing agent. Ingat yang tu, jangan terbalik. Okay, as simple as that. Benda ni benda asas, benda senang. Okay, benda ni benda senang, tak ada isu. Yang kita nak masuk sekarang adalah kita nak masuk kepada your cell notation. So over here, I want you to pay attention a bit. Cell notation is what? Okay, cell notation is actually the shorthand notation for your galvanic cell. Kamu kan suka belajar short form. Teacher ada short form, teacher short form. Ni short form, belajarlah. Okay, so cell notation is actually the shorthand notation for your galvanic cell. Kalau saya bagi satu cell notation sebagai soalan. Soalan kata, based on the cell notation below, draw the galvanic cell. Kamu kena boleh lukis. Okay. So what is actually cell notation? Simple. Saya nak padam sedikit. That is my anode undergo oxidation. Boleh lah. Okay. So, just 1 second. That is my zinc. Okay. Your cell notation will be actually the flow from your electrode of your anode. Make sure kita start pada anode. Cari anode kat mana? Bukan start sebab kiri ya. Ni saya patut bagi anode kat kanan ni. Alright, bukan start sebab dia kiri. Kita start sebab dia anode. Cari anode kat mana? Cari electrode dia kat mana? Kita akan bergerak daripada electrode turun kepada electrolyte. Okay, so saya tulis kat sini dulu. So my cell notation will look something like this. Anode saya adalah electrode zinc. So saya pun label dia solid. Okay. Tadi Miss Wong kata apa? Daripada anode punya electrode turun kepada electrolyte dia. Electrolyte dia jumpa siapa? Electrolyte dia jumpa Zn2+ aqueous. Kalau soalan ada bagi concentration 1 molar, kita letak 1 molar tu comma, 1 molar tutup bracket. Okay, that is your cell notation at this moment untuk bahagian anode. And then next, daripada electrode turun kepada electrolyte, kita akan naik kepada salt bridge. Kita akan naik kepada salt bridge. So how do I represent the salt bridge? Salt bridge double slash. Ni adalah salt bridge. Okay. So selepas salt bridge guys, kita turun kat mana? Kita jumpa electrolytes untuk cathode. Kita jumpa copper 2+. So apa yang kamu buat? Kamu akan jumpa copper 2+ aqueous, 1.0 molar, tutup bracket. Okay. And then kita bergerak lagi. So daripada salt bridge turun jumpa electrolyte, kita akan naik jumpa apa? Kita akan jumpa electrode untuk cathode. Kita akan jumpa electrode untuk cathode. So turun, double slash pula, single slash, sorry. Kita akan turun dan kita jumpa copper solid. Okay, and that is our cell notation. Okay, so a kind reminder in your cell notation, kita ada a few things yang saya nak kamu ingatkan. This is salt bridge. This is salt bridge. Okay, double slash adalah salt bridge. Sebelum salt bridge, apa-apa yang duduk di sebelah kiri salt bridge mesti adalah anode. Bukan sebab dia duduk kiri ya, bukan. Sebab dia mesti adalah anode. Kat sebelah sini, dia mesti adalah cathode. So tak kisah lukisan saya, katakanlah Miss Wong terbalikkan lukisan tu. Okay, Miss Wong terbalikkan lukisan tu. Alright, kita terbalikkan lukisan ni sikit. Let's say I have my cathode over here. That is my positive. That is my negative. Okay. So I have my cathode over here. So that is my copper. So that is my copper 2+. And then I have my anode on this side. Okay. That is my zinc. That is my Zn2+. Okay. Kalau saya terbalikkan lukisan dia sekalipun, kita tetap akan cari anode siapa? Kita tetap akan mula bergerak daripada electrode anode, turun kepada electrolyte, naik lagi ke dalam salt bridge, turun ke dalam electrolyte untuk cathode, naik balik dan berhenti di cathode. That is what I mean. Okay? So it's not about kiri atau kanan. It's about siapa anode, siapa cathode. Okay? Yang tu yang paling penting lah. Dan yang kedua, orang yang duduk di sebelah salt bridge, orang yang duduk kiri kanan salt bridge, mesti adalah electrolytes-nya. Mesti adalah solution. Sama ada aqueous atau liquid. Okay? Alright. Dia mesti adalah your solution. Kalau duduk sebelah salt bridge, nampak tak salt bridge terendam kat mana? Salt bridge terendam dalam electrolyte, nampak? So dia mesti adalah electrolytes kiri kanan kamu. Electrolytes anode, electrolytes cathode. Okay? And last but not least, your cell notation mesti kena mula dengan electrode of the anode and mesti kena berakhir dengan electrode of your cathode. So dia mesti bermula dengan electrode solid, turun ke dalam electrolytes, naik salt bridge, lepas tu jumpa electrolytes and then jumpa balik electrode. That is your cell notation. Okay? That is your cell notation. Alright? Question so far? Okay. Alright. Sorry, tertekan. Alright. So that is your half equation. That is your overall equation. Your reducing agent, oxidizing agent, and also your cell notation. In your notes later on, yang saya akan bagi nanti, your overall equation technique, how to get your overall equation, the keyword over here adalah you are going to combine the both half with a condition you must cancel off the electron. Okay, that is your overall equation. Okay, cell notation yang ni yang kita nak tengok. Okay, cell notation, like I say, anode must be on the left and cathode must be on the right before and after your salt bridge. So your salt bridge over here will be represented by the double slash atau double vertical line, and your single vertical line will be used to indicate the phase boundary difference. Kalau tadi kita ada solid dengan aqueous, so kita guna slash lah. Kalau kita ada aqueous dengan aqueous, kita guna comma. Okay, contoh ya, saya boleh ada bromine to liquid, dia akan jadi Br minus liquid. Okay, so kamu nampak dia berubah daripada bromine liquid kepada bromine liquid, so kita guna comma lah. Okay, kalau dia same phase kita akan guna comma, kalau dia different phase kita akan guna slash ataupun vertical line. Okay, certain buku akan tulis macam ni tau, certain buku akan tulis slash. Okay, certain buku akan tulis slash and then Zn2 plus, sorry, solid, and then Zn2 plus aqueous. Slash pun boleh, slash pun kita terima, vertical line pun kita terima. Kamu akan banyak nampak saya guna vertical line. Okay, alright, dua-dua kita terima. Alright, sama je. Okay, what is actually the function of salt bridge? So kita ada two functions, we have two functions, but the main function is actually this. Alright, the first function, we are going to complete the electrical circuit. If you don't have the salt bridge, you will then realize your circuit is not complete. The second is actually to maintain the electrical neutrality between the two electrons. This is the main function. Both are the main function actually, but this is the one that the question always asks you to explain. So the first one, we need to complete the electrical circuit. So you can see over here at the top between the electrode, that is actually your wire connecting to your voltmeter. So how do we complete the circuit? The salt bridge. Then only you form a complete circuit over here. All right, that is what we mean by complete the circuit. Okay, the second thing is to maintain the electrical neutrality. So what is meant by maintain the electrical neutrality is quite simple actually. We agree on the anode, your zinc will then forming zinc 2 plus. Sayang, original dia dah banyak zinc 2 plus dah. Bukan dah banyak, dia dah ada zinc 2 plus. Lepas tu zinc ni akan berubah pula jadi zinc 2 plus. So lagi banyak zinc 2 plus akan terhasil. Dengan kata lain, concentration zinc 2 plus akan increase. Okay? And when the concentration of the zinc 2 plus increase, your anode will have a lot of positive charge. Okay? Positive charge will be excess in here. Apa jadi pula pada cathode? Cathode electrons go in. When electrons go in, Cu2 plus akan ambil elektron tersebut dan jadi copper solid. Alright, so Cu2 plus akan decrease. So concentration Cu2 plus decrease, and ion akan jadi excess. And ion siapa akan jadi excess? Remember copper NO3? Alright, if you remember, you have your copper nitrate over here. So your NO3 minus yang tak buat kerja tu, NO3 minus yang tak buat apa tu akan tiba-tiba jadi, dia bukan banyak, dia kekal, concentration dia kekal. Tapi sebab concentration cation turun, so anion jadi berlebihan. Okay, so you can see over here, when your Cu2 plus is used up, your cathode will have the excess of your anion. Alright, kat sini lebih negatif. Kat sini lebih negative charge. Kat sini lebih positive charge. Tak balance weh. Satu lebih positif, satu lebih negatif. So apa salt bridge buat? Salt bridge is actually a salt that have a cation and anion. Oh sorry, NO3 minus. Okay, salt bridge adalah orang yang pegang cation dengan anion. So apa kerja salt bridge? Kat sini lebih positif. Oh, so dia tak cukup negatif. So NO3 plus pun turun, rescue. NO3 plus pun turun kat sini, rescue. Bagi cukup balik negatif tu. Kat sini pula, lebih negatif. Positif tak cukup. So K plus pun turun, rescue dia. Bagi balance balik. That is what we mean by maintain the electrical neutrality. Alright, we are going to maintain by using the positive charge neutrality. Okay, so kita akan turunkan the positive charge and the negative charge untuk dia balance balik. Dan cara yang senang nak hafal adalah, nampak anode? Okay, nampak anode? So anode, siapa masuk ke anode? Anion masuk ke anode. So anion akan masuk ke anode, cation akan masuk ke cathode dari salt bridge. Itu cara senang nak tahu. Tapi cara untuk explain kenapa anion masuk pada anode, kenapa anion nak masuk pada anode. Sebab di anode, Zn2 plus ataupun cation will be excess. Positive charge will be excess, so we put in negative ion. Pada cathode pula, kenapa cation akan masuk pada cathode? Senang. Because I have extra negative charge. I have more negative charge than the positive. So, positive charge pun turunlah, balancekan dia. And that is the function of your salt bridge. And favorite question, guys. Favorite question. Okay? So, make sure you know how to explain the function of salt bridge by explaining how to maintain the electrical neutrality. Okay? Boleh tulis macam saya tulis, letak je equation, letak je ayat yang saya ada. My slide over here, my PowerPoint slide over here is actually your answer. Okay? Okay, question so far? No? Okay. The next thing that we are going to learn is actually something to do with your calculation, but your calculation, you will learn it in your tutorial. So I'll teach you the basic of the calculation only. Okay? So first and foremost, the electrode potential. Kita banyak new term. So what is actually electrode potential? If you remember just now, in every single galvanic cell, kita ada beaker, kita ada salt bridge terendam. And if you remember, we have one thing. We have electrode, wattmeter, we have another electrode. Betul? So I told you that the changes that we have in our galvanic cell is your chemical energy to your electrical energy. So, macam mana electric terhasil? Because of the energy potential of the electron. Setiap satu electrode akan ada potential energy dia yang sendiri. Every single electrode will have their own potential energy. So kat sini tadi kita ada zinc, kat sini tadi kita ada copper. So zinc akan ada electrode potential dia sendiri, copper akan ada electrode potential dia sendiri. Okay, that is what we mean by, that is what we call electrode potential. Kalau kamu biasa jumpa, kamu akan biasa jumpa benda ni. E cathode, E anode. Yang kamu belajar dalam calculation. Yang tu adalah electrode potential. Okay, that is actually form, or that energy, or the electrode potential energy is actually depends on how fast or how easy your metal can become ion, or your ion can become the metal. Okay, that is how we measure the potential energy. Okay, tak ada apa kat situ. Yang ni, what makes it different from here to the other slide? E juga, electrode potential juga. Apa beza dia? Standard. Remember your chapter 2? Standard enthalpy of combustion, standard enthalpy of neutralization. Ingat standard tu? That is the same standard. But the same standard right now, at the standard condition, ada satu benda lebih. Concentration. Selain daripada pressure 1 atm, temperature 25 degrees Celsius, you have one more new thing. Your concentration of your electrolytes must be 1 molar. The pressure must be in 1 atm. The temperature must be in 25 degrees Celsius. And this, alright, yang ni kalau kamu kira, dia akan jadi E0 cathode. And then kamu akan ada E0 anode. Okay, yang ni yang kita akan biasa jumpa sebenarnya. Alright, yang tadi kita jarang jumpa. Kalau kita nak measure apa-apa, biasa kita akan letak dia dalam standard condition. Alright, that is your standard electrode potential. And in the other words, in the other words, kalau saya nak lukis, Nak lukis, malas nak lukis. Ni. Malas nak lukis. Dia tak. Okay. So in the other words, your anode over here of your zinc, guys, your anode of your zinc over here, E naught anode is actually your E naught of your zinc, which is your Zn/Zn2 plus. Over here is your E naught cathode. Cathode punya. Cathode kita hari ni siapa? Cathode kita hari ni adalah copper 2 plus copper. Nampak tak? Dari apa jadi apa? Alright. Dari apa jadi apa? Oops. Alright. That is your E naught, E naught. Okay. And we agree on this E naught akan ada satu value berapa watt. This E naught akan ada satu value berapa watt. So bila diorang compare, barulah diorang dapat 1.103 watt. Okay. Watt meter using watt. Yes. 1.103 watt. Okay. So the question is, saya compare zinc dengan copper, saya dapat 1.103. Tapi kalau katakanlah teacher kata zinc adalah 0.05. Alright, copper adalah positif 1.73. Katakan saya tak ingat, saya letak random je. So the question is right now, the question will be, macam mana Miss Wong tahu dia banyak ni? Macam mana kita tahu dia adalah value dia sendiri tu berapa? Zinc ada satu value, copper ada satu value, magnesium ada satu value, aluminium ada satu value. But the question is, macam mana kita tahu value dia berapa? Betul? That is the problem. So, we come across this thing. Standard hydrogen electrode. Nama pendek SHE. Kita memang panggil dia SHE. Okay? So, dalam banyak-banyak elemen yang kita ada, we have a lot of element in your periodic table. Okay, when you have a lot of element in your periodic table, we have your calcium, barium, potassium, magnesium, aluminium, zinc, what else? Fluorine, chlorine, bromine, iodine. Semua benda tu ada electrode potential dia sendiri. Dia ada tenaga dia sendiri. Tapi soalan dia adalah, macam mana aku nak tahu tenaga dia? Macam mana you tahu tenaga dia 0.53? Macam mana you tahu tenaga dia 1.13? Betul? Then, somebody, alright, saya tak tahu siapa, tak ingat nama dia siapa, somebody yang dah mati lama tu, yang kalau kamu mimpi, kamu salah buat tu, dia mimpi dia datang cekik kamu tu. Somebody decided to make hydrogen as a standard and electrode potential of hydrogen gas, alright, to hydrogen positive, hydrogen positive to hydrogen gas. Hydrogen positive to hydrogen gas, Hydrogen positive to hydrogen gas. Yes. Somebody decided to make your hydrogen equals to 0. Okay. So kalau kita nak tahu something tu adalah berapa, senang je. Kita compare dengan orang yang kosong. Betul? Kita compare dengan orang yang kosong, kita baca wattmeter dia, oh wattmeter dia 0.57. Oh dia 0.57. Sebab apa? Sebab saya compare dengan hydrogen yang kosong. Okay. So always remember one thing, your standard hydrogen electrode, your SHE, is where we decided the potential energy is 0. Alright? The electrode potential is 0 untuk hydrogen. That's why, contoh, that is my SHE, that is my hydrogen gas. Kita nampak, yang ni adalah hydrogen gas, hydrogen dalam bentuk gas, kita masukkan dia lah. Alright, kita masukkan dia. Boleh saya label SHE anode. She's platinum. Kita biasa guna platinum. Platinum adalah inert electrode. Alright, kita biasa guna platinum solid. So that is my platinum solid. That is my electrolytes. Okay, that is my electrolytes untuk hydrogen. So, hydrogen nampak tak electron flow? Nampak tak electron flow? Soalan saya sayang. Kalau elektron adalah flow daripada hydrogen kepada Ag cathode. Oh, dia dah bagi tahu dah. So automatically pacik ni jadi cathode lah sebab elektron bergerak ke dia. So pacik ni automatically jadi anode. Alright, so bear that in mind, anode is the one that undergo oxidation. Cathode is the one that undergo reduction. Okay, jangan lupa. Benda ni benda asas. Anode negatif, cathode positif. Jangan lupa benda ni. Okay. So from here, you can see the value that you obtain, guys. The value yang kamu dapat, 0.08. Dan kita semua orang tahu, hydrogen E0 untuk hidrogen adalah kosong. Betul? Kalau dia adalah kosong dan saya compare untuk Ag, bermakna E0 untuk Ag adalah berapa kelas? E0 untuk Ag adalah berapa kelas? Are we still together? Sorry?
0.8.
0.8 betul sayang. Positif 0.8. Okay? Positif 0.8. Alright? So, that is how we get the E0 value. That is how you get all your E0 value. As simple as kita compare dengan hydrogen. Alright? And what is the function of hydrogen? Untuk cari all the E0 value. Okay? So that is the electrode potential at the standard condition. Standard condition bermakna pacik ni mesti adalah 1 molar. Temperature adalah 25 degrees Celsius. Pacik ni adalah 1 atm. That is our E0 value. Standard condition. Okay? Simple. Very simple. Alright? And last but not least, before we move on, kita tak move on lagi ni. The cell potential is the potential difference. Yang ni tak ada apa. Alah, yang ni weh. Soalan saya satu je. Cathode minus anode or anode minus cathode? Untuk dapat E cell.
Cathode minus anode.
Kita hanya guna satu ya. Kita tak guna yang reduction dengan oxidation. Saya malas. Bukan saya malas. Saya tak nak kamu buat silap yang apa-apa. So kita hanya akan guna satu. E cell equals to E cathode minus E anode. And what makes it different when you have a standard? When you have a standard, you will have your standard cell potential. That is your E0 cathode minus E0 anode. Okay, that is your E0 cathode minus E0 anode. Okay, setakat ni ada soalan? Kalau tak ada, kita balik. Ya, kita balik kepada yang ni. So tadi kita dah belajar the E0 adalah apa, the E0 adalah apa. So apa beza E0? E0 ni adalah what we call electrode potential. Alright, this is what we call electrode potential. Potential. Last yang kita belajar adalah cell potential. Yang last yang kita belajar tadi adalah cell potential. Apa maksud cell potential dengan electrode potential? Electrode potential adalah dia punya. Yang ni adalah electrode potential. Cell potential adalah the total. So the total adalah E0 cathode minus E0 anode. Itu beza dia. Alright. Electrode potential adalah separuh. Dia punya. Cell potential adalah semua orang punya. Okay. Total beza berapa? That is your cell potential. Okay. And before we move on, there is something that I want to show you. Right? Tak ada. Ni. Alright. Okay. So if you look at here, this table ada dan this table sangat-sangat penting dalam this chapter. Okay. 1 second. Okay. Okay. Memang tak jelas ya, memang tak jelas. Kamu akan ada yang jelas di belakang nota kamu atau di belakang buku tutor kamu. Okay. Duka cita dimaklumkan. This table will not be given in the exam. Kata semua, oh my god. Okay. Dan suka cita dimaklumkan, the table won't be given, but the value will be given. This value, alright, value yang ada kat belakang ni will be given. Okay. But you need to know how to use the value. Dia hanya akan bagi value, dia takkan bagi the complete table like this. Okay. So if you look at it, that is your standard reduction potential table. Value ni datang dari mana? Value ni datang dari mana? Value ni datang apabila semua orang ini compare dengan hidrogen. Semua orang ini compare dengan SHE dan kita akan dapat value ni. Sebab SHE adalah 0.0 volt. Okay? So that is the value that you get first. Second, look at the word reduction. Standard reduction potential table. Nama lain SRP table. Alright, your SRP table over here, ladies and gentlemen. Saya tak tahu kamu perasan ke tak, tapi sila perasan sekarang. Semua orang dalam reduction. Semua orang dalam bentuk reduction. Kenapa semua orang dalam bentuk reduction? Simple je. Sebab saya nak compare. Saya nak letak semua orang dalam satu jadual yang sama. Bila saya nak letak semua orang dalam satu jadual yang sama, semua kena duduk dalam bentuk yang sama. Therefore, over here, everything is in the form of reduction. Okay? So, berhati-hati bila kamu ambil equation ni. Kalau kamu ambil untuk cathode, dia tak ada masalah. Cathode sebab cathode undergo reduction. Kamu ambil je. Tapi bila kamu ambil untuk anode, dan kamu kena berhati-hati. Okay, ingat dia adalah standard reduction potential. Kalau kamu ambil untuk anode, that is not a problem. Tapi bila kamu ambil untuk anode, kamu kena terbalikkan equation tu. Okay, kamu kena terbalikkan equation tu. Alright, so we are going to use a lot of this table. Make sure you know how to use the table later on in your tutorial. Make sure you learn this. Okay, saya nak ajar sedikit kat sini. Alright. Saya nak ajar calculation. Satu calculation yang simple je. Boleh lah. Kita tengok soalan 2. A. Quick question. Siapa anode, siapa cathode? This one. Siapa anode?
MG anode.
MG adalah anode. Kenapa sayang?
Sebab electron flow from MG to AL.
Yeah. Electron flow from MG to AL, which means that is my oxidation. That is my reduction. Agree? Okay. Simple ya. The tips, electron flow. Seperti yang kita setuju. Alright. So, my E0 cell. Kalau saya nak kira E0 cell. Assume dia satu ya. Assume dia satu. Yang ni bukan soalan calculation. Cuma saya nak jadikan dia soalan calculation. Assume dia satu. So, my E0 cell will be my E0 cathode. Alright. Minus my E0 anode. Okay. So, my E0 cathode adalah siapa? Cathode saya adalah aluminium. So, kita nak buat macam mana? Calculation dia macam mana? Senang je. Pergi pada table kamu. Pergi pada table ni, cari aluminium kat mana. So, saya pun cari, saya jumpa aluminium kat sini. Nampak tak aluminium? So, aluminium saya sekarang adalah negatif 1.66. So, saya pun masukkan value saya. Value cathode saya negatif 1.66. Okay. Minus anode. Anode saya siapa? Anode saya magnesium kawan-kawan. Alright. Kita pun pergi kat table tu macam biasa. Kita cari magnesium. Magnesium Mg2 plus kita jumpa. Over here. Negatif 2.37. Alright. Saya pun ambil lah. Negatif 2.37. Dan saya nak kamu perasan satu benda je. Saya ambil tak positif dengan negatif sign tu. Kita ambil ya. Kita ambil dan kita kira sekali dengan positif dan negatif sign tersebut. So bila kamu kira, anybody can you press the calculator for me? Dapat berapa?
0.71.
0.71. Jawapan 0.71 atau jawapan saya positif 0.71?
Positif.
Positif 0.71 unit volt. Nampak?
Nampak
As
Adam.
simple as, sayang, as simple as kamu kena detect siapa anode, siapa cathode correctly. Dan when you use the formula, I say be careful when you take the equation. Alright, I only say just now be careful when you take the equation sebab equation dalam bentuk reduction. Tapi bila masuk dalam formula ini, formula cathode minus anode, kita tak payah ubah value kalau dia dalam bentuk reduction, kita ambil sahaja. Okay, dia mesti kena dalam bentuk reduction sebab kita tengah compare dia orang. Alright, bila kamu tengah compare anode cathode, kita kena compare dalam bentuk yang sama dan satu dunia guna bentuknya adalah reduction. Kalau hang gigih hang nak tukar semua dalam oxidation, buatlah. Hang terbalikkanlah semua benda dalam table tu. Okay, and you're not that smart, so don't do it. Okay, so equation kena berhati-hati bila kamu ambil, dia kena terbalik. Tapi value untuk masuk dalam calculation tak payah. Formula dia as simple as this. I don't know whether you realize how simple it is or not, but the most important thing before you do anything, who is my anode, who is my cathode? Okay, so before I end today's lesson, how do we determine? The problem is how to know who is anode, who is cathode. Betul? That is the biggest problem lah, because that is the most important thing. So first, electron flow yang saya keep on ajar. Kalau soalan bagi diagram, electron flow. Okay, yang pertama. Yang kedua, kamu boleh tahu adalah daripada terminal of your voltmeter. Alright, the terminal of your voltmeter. This is the biggest tips that I can give to you. So if the question already stated over here negative, the question stated here positive. Dia tak bagi electron flow. Dia tak bagi electron flow ni. Alright, dia tak bagi electron flow, tapi kamu boleh tahu siapa anode cathode sebab kamu tengok positif negatif tu. Kalau dia tak bagi yang ni pun. Alright, so yang kedua adalah the terminal of the voltmeter if the question are giving you the diagram. Okay, next. Kalau soalan bermula dengan what do we call that? Cell notation. Alright, I hope you remember your cell notation adalah anode and then short bridge and then cathode. So make sure kalau soalan bagi cell notation, kamu boleh baca cell notation tu knowing that your anode must be the one that's starting on the left. Okay, boleh setakat ni? And then cara keempat dan cara yang kita selalu guna adalah E0 value. Kita akan tengok E0 value yang soalan yang ni bagi. Alright, macam saya cakap, dia tak bagi table. Tapi dia akan, last thing. Last and most important thing. Dia akan ada this E0, this value given in your question. Alright, saya dah bagi tips dah kat sini. This is the increasing of your oxidizing agent. Increasing strength of oxidizing agent. Knowing that oxidizing agent means undergo reduction. Okay, undergo reduction. Bermakna orang yang duduk di atas akan cenderung ke reduction. Orang yang duduk di bawah akan cenderung ke oxidation. Okay, so tengok pada value. Sebab exam tak bagi jadual weh. Problem, exam tak bagi jadual Miss Wong. Okay, that is the problem. So, we can only compare the value. Saya tak tahu kamu perasan tak, table ni dia disusun ikut value yang paling positif. Nampak positif 2.87. Positif akan turun sehingga kamu jumpa kosong. Siapa kosong? Our hydrogen. Okay, dan nampak tak dia bergerak ke negatif. Increasing of the negative. All the way down to your negative 3.05. Okay. So, dengan kata lain, siapa yang akan undergo reduction? Orang yang akan undergo reduction adalah E0 that is more positive. Okay. Vice versa, siapa undergo oxidation? E0 that is more negative. Okay. So, cara keempat yang saya hutang kamu tadi adalah E0 value. How do I determine the anode cathode? How can I know which one will be the anode, which one will be the cathode? E naught value more positive akan jadi apa? Akan jadi reduction. So reduction bermakna apa? Reduction bermakna cathode. Alright. E naught value more negative. E naught value more negative means they akan undergo oxidation. Oxidation means anode. And this is the important thing. There is a lot of important thing for today's lecture, but this is one of the most basic and important thing for this entire chapter, which is getting your anode. Who is your anode? Who is your cathode? Okay, this is a summary that I can give to you, other than all the basic thing about how to draw your how to draw your galvanic cell, how to write your cell notation, and etc. Any question? All right, if you have any question, you can drop by and ask. And if there is no question, that is your attendance. Please take your attendance and have a good day. I'll see you guys around. Oh, sebelum tu, masih ada dan dengar kan? Hari Jumaat petang pukul 3 kita akan buat extra class. Hari Jumaat petang pukul 3 kita akan buat extra class. Friday, 3 p.m. extra class. And yes, please hate me. Have a good day. I'll see you guys around. Welcome back. Stay safe and take good care of yourself.
Thank you, madam.
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 Lima-lima kau
Thank you, madam.
Thank you, madam.